Yeah, Josh. Hello. Cannot hear you. I think you should enable your microphone when you join the I think there's an option of
Hello.
Oh yeah, there you go.
Johnny.
I can hear you now.
All right, sweet, perfect.
Great. So what did you do? Did you just wait or?
Pardon? Oh, I wasn't too busy. I had other things to do as well, so I was just like, that was all right for me.
I mean, like, what did you do just back then to enable your microphone?
Oh, I just went to the bottom left-hand corner and it said
Mhm.
join computer audio or whatever.
Join computer audio. Okay.
Yeah. Hey, Johnny.
Mm-hmm.
In class, we've been working on series and compound interest. I was wondering if we could go through series, especially because we started learning about series right before our trials, and I
Yeah,
was
that's
like,
right.
all right, screw this. I want to focus on my trials. So I
Mm-hmm.
didn't pay too much attention to series. So I was wondering, could we go through that?
Yeah, sure. You can enable your video if you want.
Oh, right. Yeah. Okay.
Yeah,
Sure. That doesn't make it any glitchier or anything.
that's all good. It's just one-on-one, so.
Oh, okay. Sweet.
Yeah, so we're just going to look at a sample paper and see what the compound interest thing looks like.
Yeah, sure.
Yeah,
So
it's
what paper is
usually
this? 2015?
2015, yes. It's probably this one here, right?
Okay.
So this is definitely worth trying.
So right now, you should assume that I am pretty much useless at this type of question, but
What do you mean by useless?
as in like I don't know much of it. I'm at the very basics in terms of this question right now.
Okay.
In this style of question.
Yeah, but they always come up in the same way. So
Okay, sure.
yeah, it's just
So this
all
is a
about getting
compound interest question, correct?
There are two types. One is compound interest.
Mm-hmm.
Another one is investment or loan repayment or superannuation problem.
Right,
Right.
okay.
So hold on. Under two. Okay. Yeah. So one case is compound interest,
Uh-huh.
and this one is very simple. But
Yeah.
this one over here is a loan repayment.
Yeah, we haven't done loans yet. We've just got up to compound interest.
Okay, repayment and like investment type. The difference is compound interest is when you just make one payment only, one
Mm-hmm.
investment, and this one just keeps on getting some interest. And this is just
Okay.
one investment. So the formula is, so I'm gonna give you an example. So maybe let's say
Sure.
you put $1,000,
Yeah.
and then the interest is 12% per annum,
Mm-hmm.
and it says compounded annually.
Yeah, so that's 12 months.
Yeah. So they can say. So I'm gonna say question one. Just give me a second. Okay, I'm gonna say compounded, first of all, annually.
Mm-hmm.
But they could say compounded monthly.
Mm-hmm.
So if it's compounded annually, then all you have to do is, so let's say they want you to find out the amount of money after 1 year.
Mm-hmm.
Then all you have to do is 1,000 times by, that's the original amount,
Mm-hmm.
1.12, because 1.12 is 12%, isn't it?
Yeah.
And to the power of 1, because I said annually. So what is the balance after 1 year?
Yeah. Balance after 1 year would
So 1 year.
be
So this is just one year here, and this is the interest for 1 year, isn't it?
Mm-hmm.
This is the interest per year, and this number here is year, isn't it?
Mm-hmm.
So if I say balance after 2 years, all you have to do is just plug in 2 here.
Right.
Okay, 3 years and 3 there. So if we do calculator, I really should put this one down over here.
Do you want me to calculate it and see what I get?
Yeah, so this one is really easy. This is just a 1,120.
Yeah.
So 1120. So that's how much money you'll get.
Yeah, that's what I got as well. Uh-huh.
And if you want to do maybe 10 years, then all you
Mm-hmm.
have to do is just take this calculator.
Change the power.
Yeah, change
Is
the
it
power.
is it 3,105?
Did I say 10 years?
Yeah.
Yeah, so this one times by 1.12 to the power of 10. So that's 3,105, okay?
Uh-huh.
Now let's say this one is compounded monthly.
Yeah.
And we want to know the balance after 1 year.
Yep.
So 1,000 times by 1.12, because that's for
Just with the above question, Johnny,
yep.
in relation to when you said 10 years,
Mm-hmm.
to what degree do we have to consider the decimal places?
Because it's money, just consider up to 2 decimal places.
Okay, sure, because that's cents, correct?
Yep.
Okay. Okay, cheers. All right. Yep, continue.
Mm-hmm. We're going to consider this one here, monthly. Balance after 1 year. So all you have to do, you see this one here, 12%?
Yeah.
If you divide that by 12 months, you just get 1% per month.
Mm-hmm.
So this will be 1,000 times by 1.01.
Uh-huh.
Makes sense?
Yeah.
And it's the power of how much? It's 1 year.
So 12 months.
It's actually 12. Yeah, that's right. So instead of 1, because it's compounded monthly,
Uh-huh.
you have to put number of months there. So let me ask you this, Ajesh, before you calculate this one.
So it's 12% time divided by 12, right? Or is it
Yeah.
1.12 divided by 12?
Oh, it's just 12 divided by, you just divide the percent by 12,
Yeah.
and you get the
Oh.
percentage, and
Uh-huh.
then this is equal to 0.01, isn't it?
Mm.
So don't do 1.12 divided by 12.
Mm-hmm.
So this is wrong. So 1 is always there, and then this is the percent.
Yeah.
Okay, so it's
Got it.
it's 1%. So because it's 12% divided by 12, so
Mm-hmm.
0, 1 like that. Okay.
Yeah.
Yeah. By the way, I'm really, really thankful that you are still alive.
Yeah.
Yeah.
All right.
I
Yeah,
was
no,
really,
sorry.
yeah,
Sorry
that
about
was
that.
that's a bad joke. Okay.
Yeah, yeah.
Yeah.
Definitely learnt my lesson from that one.
Oh,
But
did you get into trouble?
not too much trouble. I just realized that it wasn't a nice joke to make because
Yeah,
you screw with people's emotions. So.
that's right. Yeah. Did your parents find out as well?
No, luckily they didn't.
They
But
didn't.
I had a few teachers that I have on Facebook saw it, and then I was like, oh, okay, probably shouldn't.
Yeah.
Yeah.
I was really shocked as well.
Mm, yeah.
Yeah.
It
I
was
thought you
nice.
got into like a car accident or something.
Yeah.
Because you always go back tired
Tired.
or something.
Yeah.
And then while
Nah,
you're driving.
that
Oh.
logically would probably be the most likely reason
Mm.
if I was to.
Anyway, drive safe and yeah,
Yeah, I
you're
will.
alive. All right.
Will do.
Okay, so this is so would this be greater amount, or would you rather have this one compounded monthly? Would that give you more money?
Let me calculate it.
Or don't calculate it, just tell me.
Oh,
Would this be more? This is 1 year, this is also 1 year, right?
yeah.
But is it better to just compound it once at
Yeah.
12%, or is it better to get compounded monthly every month at 1%?
Probably monthly.
Yeah, so I want you to calculate this one and see the difference.
How's your baby, by the way?
Oh, pretty good.
That's good. Congratulations on it.
Thank you.
Yeah. It's actually higher. The $1,126.
Yeah, this is higher.
Mm.
Did you want this one or this one?
I thought 2 would be the better option, but clearly
Yeah,
it's
2 is
not.
the better option. This is higher.
Mm. Oh, you want it? Do you want it higher?
Yeah, of course you get more money.
Oh, yeah, true. Yeah, I thought you were paying. Oops.
Oh, you're not paying. This is your money. You invest it, and
Yeah.
then you put it in a bank, and that gets compounded.
Right.
So
Yeah.
this
Yeah.
is higher. So this is 1,000 times by 1.01 to the power of 12, and you get $6 more.
Mm-hmm.
1126 point how much? 8.
Right.
Yeah.
Just a question, Johnny. Why is it
Mhm.
1.01 instead of just... Yeah, why is it 1.01?
Because it's 1%.
So you always have the 1 in front of it.
Yeah, you always have the 1 in front of it.
Okay.
Do you want me to tell you the reason why?
Yes, please.
So this 1 represents the original amount.
Right.
Because if you multiply 1,000
Yes.
by 1, then you get 1,000, right?
Yeah.
So that means you multiply by 1 to get the original amount. I'll show you something. So, like if you have, let's say you have $1,000,
Mm-hmm.
and this one goes through 5% of interest.
Yeah.
So you're going to gain 5%. So let's calculate 5%. So if you multiply 1,000 by 5%, which is 0.05, you're going to get $50.
Mm-hmm.
So what is your balance then?
$50.
No, your balance is going to be 1,050.
Oh, yeah,
Is that
true.
right?
Yeah,
So
yeah.
how do you go? So this is the reason why I multiply by 1.05 instead of 0.05. So this 0 here, this 5 there represents for 5%. And this
Okay.
1 here represents for the original amount.
Mm-hmm.
So if you do this, then you're going to get 1,050 instead of just $50.
Okay, got it.
Got it?
Yeah.
Okay. So we're going to look at some maybe loan repayment question. I mean, the compound interest problems, okay,
Mm-hmm.
that are similar to. Let's have a look.
Interesting.
All right.
What's your baby's name?
Yeden.
Oh, that's a nice name.
Yeden.
Yeah, that's a really nice name.
Yeden. Yeah. It's a unique name.
Yeah, I've never heard Yeden.
It works both in Korean and English
Oh, right. Yeah.
well. So yeah. All right. So let's try some questions from here. Yeah, this one is pretty good. Hold on. Yeah, this one. Yep. So all these questions are pretty good.
Mm-hmm.
So all of this are compound interest. So these are not loan repayment stuff. Okay.
Mm-hmm.
So these are all. So this is not compound. This is arithmetic. So just skip number 1. That's not related to the HSC.
Mm-hmm.
So question 2 says, Karen invests $2,000 in an account paying 8% per year. How much is it worth 4 years? So we're going to assume that this is a compounded annually. Okay, so this is a compounded annually. It doesn't say that, so we just have to assume this one, not monthly. So we just have to do, for question 2, it's $2,000 times by 1.08 to the power of 4. Does it all make sense to you?
Yeah, can I just quickly write down the notes and then I'll quickly 8,000 and 4 years.
Have you been to my new office yet?
The one in the new math building.
Oh yeah, that's right.
Yeah,
I think you have, right? Yeah.
Yeah, I just haven't come properly to that in ages because I've been so sick. $2,000 times 1.082. Yeah, got this. And do you want me to calculate it?
Oh, it doesn't matter. Just leave it.
Okay.
So as long as you understand the concept.
Yeah, right? Yeah, I get it.
So let's go for number 3, okay?
Sure.
Anders invests 50,000 Danish kroner at 12% per year. How much is it worth after 6 years?
All right. You want me to do that?
Just tell me what it is. 50,000.
Sure.
How do you do it?
So you times 50,000 by 1.12 to the power of 6.
That's right. Okay, number 4. This one is we're going to come back to this one. This is, I think, the loan repayment stuff.
Okay. Is that question 4?
Yeah, we're going to skip this one for now.
Yeah.
Number 5. If you wants to invest 50,000 yen with a return of 20,000 yen over 8 years, what % rate must she find?
So here you got to manipulate the equation.
Yeah, so what it means is, you see how this guy invested $50,000 in question 3 over in 12% interest over 6 years, right?
Yeah, so we're missing the interest.
We haven't calculated this one, but let's figure out. So $50,000 times by 1.12 to the power of 6. And this gives us like a lot.
Yeah.
98691. 98691.
Yeah.
Now, this one here is how much return? What is the return in this case? So your $50,000 became 98,691, right? So the return is the difference between those two. So purely, from the interest, you earned 48691 from interest. Is that right? Yeah. So that's the return. So in question 5, we have to construct equations. So the 50,000 yen with some percent becomes how much? The return must be how much?
20,000.
It says you want to invest 50,000 with a return of 20,000, right? So this value must be 70,000. Make sense? You want your $50,000 to become $70,000. And this is some percent. We're going to call this R to the power of over 8 years, right? Okay. And let's solve this one. So R to the 8 is equal to 7 on 5. 70,000 divided by 50,000 is 7 on 5. So R is equal to 8 root of 7 on 5. So this is the 8th root of 7 over 5. If we try that, that's a 1.043.
Mm-hmm.
42, yeah, if you just round it up. So this is a 1.043. So this means 4.3%.
Mm-hmm.
Are you still with me?
Yeah, I was just writing down the
Mhm.
question. Okay, I kind of get that actually.
Kind of get that?
So that 7/5 is just where the zeros have cancelled out. Hey,
Yeah. So this is
okay.
just the same as a 70,000.
Can I just, yeah, I'll write down that working because that's actually really good.
Yeah, this is 7 on 5, like that. Okay.
Yeah.
So this is a,
So because he wants a return of 20,000 yen, so therefore it
yeah.
has to be
So you
70,000.
don't want $50,000 to become $20,000.
Yeah,
You want 50,000 to become 70,000 because
yeah,
7 is 20.
yeah. Okay. Do you have to do like a lot of these questions? I mean, these types of calculations in day-to-day life?
No,
Really?
well, you don't really. Banks, they do this for you.
Yeah, true.
Yeah. All you have to just work out how much money you can afford
Mm-hmm.
every month.
True. Is that hard or not?
No, no. Now, number, yeah, yeah. All these
Oh,
interest and these are just calculated by banks. So
right.
number 5 is done, right?
Yeah.
Number 6 is so you can try that yourself, I think.
Yeah. Can I
Um,
write down that question?
yeah.
Sweet. If it's final,
Mm-hmm.
does that mean you have to take it away?
Well, this is the equation. So final, you don't have to take it away. So this
Oh,
is the
okay.
final
All
figure.
right. All right. I'll give it a go and see
Mhm.
what I get. It's crazy to think we graduate in 15 days.
That's good.
Okay.
Yeah, that's great.
Yeah. Okay. So it's P times 1.08
I
power
heard that once you graduate, like it feels weird to go back to school.
4.
And
Yeah.
all the year 11 students will be thinking like, what are you still doing here?
Yeah.
Because you still have to, sit the exam.
Yeah. So you have to walk into school, but at least you don't have to go for like the last
Yeah.
like the first few days of term and stuff. Hey Johnny, would you just divide by 1.08 to the power of 4?
1.08. Yeah. So 12,000 divided by 1.08 to the power of 4. That's right.
Okay.
Because this is the equation, right? P times by 1.08 to the power of 4
Yeah.
equals to 12,000 like that.
Okay. Let me calculate what I
So
get.
P is equal to 212,000 divided by 1.08 to the power of 4.
Which is 8,820.36.
Yeah, 8,820. Is that right?
Yep.
Yeah. That's how much
So,
you have to
so what
invest.
does P stand for?
The principal.
Right.
That's the original amount.
All right. Sweet.
Okay, so I think you should try 7 and 8 yourself.
Mm-hmm.
I'll just copy and paste that. Okay.
Question 7.
Yeah, 7 and 8. I'll just send it to you, okay?
Mm-hmm. What, on Facebook?
Yep. Where's Ajesh? Oh, there you go. So now, we're going to tackle question number 4 now, okay?
Okay.
That's quite an interesting one. And let me just tell you this compound interest thing, it doesn't really show up in HSC.
Yeah? Is it more the loans?
More the loans, that's right.
Why is that? Is because the loan stuff harder?
That's right, yeah. Loan stuff is definitely harder, okay?
Mm.
And they make you go through derivation. So what I'm about to show you, you
Mm-hmm.
have to be able to derive yourself, okay?
Mm-hmm.
Now, HSC normally says A1. A is the amount, is the balance.
Mm-hmm.
Amount of balance. Now, the client benefactor sets a prize in an international school. The benefactor donates £10,000. The school invests the money in an account paying 5% interest. If the $750 pounds is paid out annually, how long can the full prize be given out? So have a look. So if you have $10,000,
So are we doing loan questions now?
yeah, we're doing loans.
Okay. All right, sweet.
So let me just describe the situation, okay? So this is
Yeah.
not really a loan, but it has the same structure as loan. So all these questions are classified as loan question, okay?
Uh-huh.
So listen very carefully. If you have $10,000 and you're giving out $750 every year
Mm.
without any, let's say you don't put this into bank account. So every year this is going down by 750. Okay.
Mm.
So let me ask you this: how long does it take until you run out of this money? Every
Doesn't that
year?
involve series?
No. It's very simple. You have You have $10,000, okay, and you spend $750 every year. How long does it take to run out of money?
Isn't it just 10,000 divided by 750?
Yeah, $10,000, 10,000 divided by 750. That's the question, okay?
Yeah. 40 over 3, 13.3.
Yes, it's going to take a little more than 13 years, right?
Yeah.
But what is described in the situation is the $10,000 is going to go through 5% of interest and then become 10,500, okay?
Mm.
10,500.
Mm.
And then you take away 750. So it's going to become 9,750. Does that make sense to you?
Yeah.
And then this 9,750 is going to go through another 5% of interest,
Mm.
right?
Yeah.
So it becomes this amount, and then you give out 750.
And then it goes through another
And then it
5%.
goes through another 5%.
Fuck. All right.
So this is what the situation is. And the question is, how long does it take?
So wouldn't it just be 10,000 times 1.05 divided by 750?
No, it's not that simple.
Oh.
It's not that simple. So definitely, so you just have to keep doing this until this becomes zero.
Fuck. Yeah. All right.
You see?
That's a long process.
That's a long process. So you can either do this and then figure out when this becomes zero. So you can see that minus 750, and then times 1.05. And by the time you get to the zero, you will probably forget how many times you did this.
Yeah,
Right.
literally.
Yeah. So that's what the loan repayment question is all about. So literally, this can be can be this: you borrow $10,000.
Yeah. Can I write this question down?
No.
Why?
I want to explain because we.
Oh yeah. Oh yeah. Can I write it down after? But
Oh, this one, I'm gonna give you this whole thing to you later,
oh,
so you can take this one. Don't have to write it. Just try to understand. Okay.
okay.
Just try to understand here. So let's say
Yeah.
you borrow $10,000. Okay. So because you have to understand this conceptually. Okay.
Yeah.
And then after that you can write it down.
Yeah.
So $10,000. Listen, $10,000. You borrow $10,000.
Yeah.
And if there's no interest, and you pay down $750 every year,
Yeah.
or let's say this is every month, all right?
Mm.
Then you can pay this in 13.3 months, right?
Right.
But then this
Correct.
$10,000 that you borrow,
Uh-huh.
gonna go through
Okay.
interest.
Yeah.
So that means you have to pay. So the balance became 10,500. You have to pay $500 more.
Yeah.
So your 750 is only going to reduce this down to 9,750, which is only $250 lower than the original amount.
Yeah.
So all that $500 is wasted.
All right. Yeah.
See? And this is what happens when you buy a house. You borrow, like for example, I borrowed the $350,000, okay,
Yeah.
from bank. Literally, I borrowed this amount, and
Oh,
this one
right.
goes through interest, okay,
Yeah.
which is about 3 points. So, but interest rate is 3.69% per year. So I have to divide this by 12, and then
Uh-huh.
divide that by 100, and then plus one to it. Then
Yeah.
this is the R. This is how much this one goes through. So
Right.
every month, if I have $350,000,
Mm.
it times this one by that interest rate, then
Mm.
because interest rate is 3.69%,
Yeah.
it is 0.3% per month,
Right.
and that is this much here.
Yeah.
And this is a real life situation. Do you know how much interest I pay?
A lot.
So it is 0.3075% of this much money.
Mm.
So, oops, no. I must be, sorry. That's not true. Um, so what this is showing us is that the $350,000 grew into
So
$351,076.
inevitably you're paying more than you actually got.
So I have to pay, you see,
Yeah.
$1,076. This is the interest here.
In total.
I mean, every month.
Oh, and then what? That's it.
So
Till all of it's paid
$350,000
off.
will grow into $351,076. All right. And I
Mm.
have to pay about $1,650 every month.
Yeah.
So this is my like monthly repayment. Okay.
And that's till you
Let's say
reach 350.
$1,676.25. And then this only reduces the balance to how much? From here to
That's
here. Only
ages.
down by $600.
Mm.
All right. And this will go through another interest of 1.003075,
Mm.
and then will become this amount. This is still over $350,000.
Yeah.
And then I pay about $1,670. All right. I'm just going to match those decimal places there. All right. Then I get, this is the balance. Okay. So this keeps on rising and then
And then dropping.
falling, rising and falling. And it takes a long time to pay back.
Right. So it could take potentially like 20 plus years.
Yeah. 20 plus 30 years, or 20 or 30 years. Okay.
Far out.
But this is still better than renting, because if you rent, you have to pay a lot. So you see, every month I'm paying about $1,000 of interest. Is it right?
Yeah.
So this is the interest.
Yeah.
So that's just dead money. You just have to pay it back.
Yeah.
But if you rent, you have to pay about $2,000 for rent.
Yeah.
So this is I'm pretty much living in my place half price of what I used to live, what I used to pay.
Right. Okay.
Yeah.
That's
Anyway,
so good.
so this is what needs to happen. So how do you solve this? Have a look. So what's A1? A1 is the amount of balance after 1 year.
Mm-hmm.
So this is 1 year. So this is the amount of balance after 1 year. And what would be A2?
Amount of balance after 2 years.
That's right. Let's figure out what A1 is. A1 is $10,000 times by 1.05, and then you have to minus 750.
Right. Okay.
Mm-hmm.
I'll whack that into my calculator.
I don't have to.
Oh.
So your question here,
Oh, I did it. It's 9,750.
yeah, but you don't have to do that.
Oh,
Just leave it like that, okay?
okay.
Because it's meaningless. It's just waste of time.
Oh,
You're not calculating this one here. Now, I'm
yeah.
going to go for A2 now. Obviously, the A2 is whatever. So what did you say was the amount here?
9,750.
9,750. Okay. So for A2, this 9,750 will go through another 0.05% interest, right?
Mm.
And then you have to minus another 750. Remember this stuff?
So yeah, what? So it's 9,750 minus 750.
No, 9,000. This one here will go through this
Oh,
much
that.
interest.
Oh, yeah.
But don't write it down yet.
Oh,
So 1.05. So this will go through the interest, and then this money will become 10,500, and then you minus 750, right?
which, yeah.
Yeah. And then this will go through another 1.05, right? Another
Minus
interest,
7.
and then minus 750. But I'm not going to use this number
Yeah.
because I'm going to use this whole thing. Okay?
Yeah.
So have a look. $10,000, 1.05 minus 750. So that is this amount here, right?
Yeah.
That amount is this one. This will go through another 1.05 and then minus 750.
Mm-hmm.
So if I expand this one out, it is equal to 1,000, 10,000 times by 1.05. So this will have to be multiplied to this
Yeah.
and this, right?
Yeah.
If I expand this one out, I mean, so this is a 10,000, 1.05 square minus this one times what this one is 750 times by 1.05 minus 750.
Yeah.
So if I factorize this one, there's a lot of maths here, so you're not going to be able to understand everything today.
Yeah.
But let's just stop writing now, all right, Ajesh, because
Yeah.
it's going to take a long time. It's maybe better to have like a quick look at what I
Conceptuals,
do.
understand. Yeah.
Just quick look at what I do, and then you can write down, okay?
Mm.
Because it's going to take a long time. So multiply this one by this one, you get this. Multiply this one by this one, you get this one. Okay?
Mm.
And then you can factorize this one into. This one here is minus 750
Mm.
times by 1.05 plus 1.
Mm.
Because this one times by this one is this one.
Mm.
Negative 750 times by 1 is negative 750, right?
Mm-hmm.
So I'm going to say I'm not going to evaluate this. This is my A2.
Yeah.
I'm going to go through A3 now. A3 is this amount go through 1.05 again and then minus 750, right?
Oh, right.
So I'm going to go through. Don't write it down, okay?
Yeah.
So I'm going to multiply this whole thing times this one by 1.05 minus 750.
Mm-hmm.
So this balance will grow by another 5% and then minus 750. And if I expand this one out, then what I get is this one times by this one is 1.05 cubed. Okay, so this one by this one whole thing here. And then
Yeah.
this one times by this one. So this is a minus 750, 1.05.
But there's a pattern to it.
There's a pattern. That's right. That's right. That's what we're trying to look at. And this becomes $10,000, 1.05 to the power of 3. And if I multiply this out, this is a minus 750, 1.05 square, 1.05 minus 750. So why not include this one in here? So this is a 10,000, 1.053, 750 here, and then 1.05 square, 1.05 plus 1. Because that one times with that one, the same as that one, okay?
Phew,
So
that's crazy.
there is a pattern, of course. So I want you to look at A2 now. If you look at A2, it's made up of 10,000. So have a look at this number. This is 2 here, right? This is 2 here. And then this was 1. And this is 1 here. So 1.01 to the power of 1. And this is 1.05 to the power of 1. And this one is 1.05 to the power of 0. Anyway, next one is A3. I want you to look at this number here, 3. And you see that this is 3 here. So 10,000 times 1.05 square.
It's 2.
This is 3. But this is what? This is
2.
2, 1, 0.
Yeah.
This is 1, 0.
So then would the next one be 4, 4, 4?
So you don't have to do
3,
4.
3,
So they'll tell you. So you up to here is enough. You always have to do up to 3. And then you have to do AN. And this will be $10,000 times by 1.05 to the power of how much?
To the power of n.
Power of n, exactly. Minus 750, and then 1.05 to the power of?
N.
No, this is 3, then this was 2. If this was 2, this was 1.
What did you just do, 3?
So this must be n minus 1.
Oh, true.
It's 1 less than this number here.
Yeah,
right?
true.
And then this one goes 1.05 to the power n minus 2 all the way down. So this decreases. If this is like 9, this is 8, this is 7, and then all the way down to 1.05 square plus 1.05 to the power 1, and then finally what?
1.5?
No.
0.5?
This is 1.05. It always ends with what?
Oh, plus 1.
Plus 1. So this is the first answer to something like this one here. So if we look at this one here, so you see? Someone borrows $100,000. This is a HSC 2015 question, okay?
Far out. That's so much just for 2 marks.
Show that A2 is this. Show that AN is this. So this is AN, right?
Yeah.
And looking very similar to what we have, right?
Yeah.
So this
That's
M
so
here,
much for 2 marks.
but it's there is always, you just memorize this technique and then you can just
Bullshit it.
this one again and again and again, okay?
Yeah.
Yeah. So this here, so this is AN. And remember, we got up to here, but we're not finished yet. You see this, how this is a long expression here?
Yeah.
This becomes the geometric sum, the series.
Oh.
So the first term is 1. The R, it's multiplied by 1.05 every time, right?
Yeah.
So this is a geometric progression with the first term being 1 and the ratio being 1.05. Therefore, and Ajesh, this is all recorded, so you can actually go back to this video, okay?
Yeah.
Yeah.
Okay.
So I think it's better for me to go fast and cover a lot of things.
Yeah.
And then you
That's
can
a
go
lot
back
better.
to this video and then watch it again.
Yeah,
And
sure.
then you can write down slowly, right? So this is a 1.05. This is your, so the geometric sum formula is given by Rn minus 1 over R minus 1, okay? This here. Now, this one to the power of, and you have to figure out how many terms there are. And there are always n many terms.
Okay.
Because how many numbers are there from 1 to n minus 1?
N.
There are n minus 1 terms.
Yeah.
So if it is a 1, 2, 3, 4, all the way up to n, how many numbers are here?
N
There
minus.
are n many.
N
There are
many.
n many.
Okay.
If you do 1, 2,
Is that the proper
3,
term to
4,
use?
all the
N
way up
many?
to n minus 1,
Yeah.
how many terms are here? There are n minus 1 many.
Yeah, okay. Is that the proper term to use?
Yeah.
Okay.
So here, from 1 to n minus 1 here, all the way up to here, so you see that this one here is a n minus 1 many terms. Right?
Yeah.
But then there is one more term here.
Yeah.
So there are n many terms. Is that right?
Yeah.
That's right. And then it's a minus 1, and then it's a 1.05, minus 1, so it's a 0.05, okay?
Yeah.
There you go. So this is the derivation of the balance of the money at nth year. So this is n is the number of years. This is after 1 year. See,
Yeah.
this is the amount of money left after 1
Phew.
year.
Yeah.
This is the money left after 2 years. This
Mm.
is the money left after 3 years.
Yeah,
This is
Jesus.
the money left after n years. Okay.
Mm.
Yeah. So it looks complicated, but what you can write is you just have to go through this like a couple of times, and then you
Mm.
just pick up the pattern, okay?
Yeah.
Apply that in the exam. That's all really. So, and then you'll be able to derive this one.
Yeah.
Now the question is, how many years does it take to get down to $0, right?
Mm.
All of this money. So let's go through that. So 0 here. So A, the balance is 0. $10,000 here.
Mm.
1.05 to the power of n, 750. And then
Minus.
1.05, 1 is just nothing, right? And then it's
Yeah.
1.05 n minus 1 over 0.05, like that.
Yeah.
And then you have to move this whole thing, so make it positive.
Mm-hmm.
And then what's a 750 divided by 0.05?
Calculate it. It is 1,000, 15,000.
15,000, okay? So basically this one here is 0 equals to 10,000, 1.05 n, and this one divided by this one is a 15,000, and then you just have that guy there. It's all multiply, so you just have to do this one and this one as 15,000,
Mm.
and then 1.05 n minus 1. Now, you expand this one out, so this is $10,000 times by 1.05 n. This one times by this one is negative 15,000 times by 1.05 n, and then negative 15,000 times by negative 1 is plus 15,000, right?
Mm-hmm.
And then this is equal to 0, 0, and this bit is equal to negative 5,000 times by 1.05 n, because it's 10,000 of this, negative 15,000 of that, okay?
Mm.
So 10,000 minus 15,000 is negative 5,000, right?
Mm.
Plus 1,500, 15,000, and then you move this term to the other side. You get 5,000 times by 1.05 n equals to 15000, and then 1.05 n is equal to 3, because 15,000 divided by 5,000 is 3.
Yeah.
And then you just have to figure out n by using log. So log of 1.05 n equals to log of 3, and this n comes out to the front. So this is n log 1.05 log 3, so therefore n is equal to log 3 over log 1.05, and this is log 3 divided by log 1.05. So it's going to take 22.51 years.
Wow.
So you see how this one went up and down and went up and down, right?
Yeah.
So without this work, without the interest, this will only take 13 years, right?
Yeah.
It takes about twice as long
Yeah.
to pay this amount. So this is about 22.51 years.
Mm-hmm.
Want you to maybe just pay attention to this one here. So this one is, you have a same problem, okay? But you can do this yourself, I think.
Mm-hmm.
$100,000. You borrow this, but then there's a rate of 0.6. So that means it's 1.006, because you divide 0.6 by 100,
Mm.
and then you plus 1 to it. So 1.006.
Mm-hmm.
So, shall we try this problem?
Yeah, sure, why not?
It may look difficult, but this is all there is, really, okay?
Mm-hmm.
Yes, it's not hard at all. It's all about just repeating the same stuff. All right. So what's A1? So this $100,000 is going to go through 1.006, right?
Mm-hmm.
And then you're going to pay M dollars. That's what it says there, M dollars, right?
Yeah.
So instead of 750, that's what you're doing.
Mm-hmm.
So in this case, you in this previous question, you were told how much you're paying every month, every year.
This time you're not.
This time you're not.
Mm.
And in the previous question, you were told figure out how long it takes to pay it all off, right? In this case, they tell you we want to pay it off in 120 payments after 120 months. Okay.
Mm.
Oh, hold on. They give you the time, and then you have to figure out the M. Okay. So they give you time, and then you have to figure out the monthly repayment.
Where's the time?
Oh, they'll tell you later. So N is the
Oh.
time. N is the number of repayments, right?
Okay.
Number of the months. Now, A2, number one is very easy. So this is A1. So you just have to do it for number one, write it like this. A1 is this.
Mm-hmm.
Then A2 is this amount will go through. So this amount, so this A1 will go through 1.006, right?
Mm-hmm.
And then minus M, true?
Yeah. Are you allowed to use just A1 like that?
Oh, you have to, of course, plug it in, then you'll find this expression here.
Yeah.
So this is equal to, what's that term times by this one?
It's in the bracket.
So it's just, so you can just put this in a bracket.
Yeah.
And then times by 1.006 minus M. We can do it like that, all right?
Yeah.
And then plug in all this, okay? So 10,000, 100,000, 1.006 minus M. Is that right?
Yeah.
And this one, if you expand this one out, you get this one.
Right.
So just all you have to do, don't worry too much, just copy this one.
And then just let it equal to that.
Just copy that one there.
Yeah.
That's equal to. So you're just using the result there.
Yeah.
1.006 square.
Yeah.
Indeed, if you multiply this one by this term here,
Yeah.
it'll be this one, right?
Yeah.
1.006, 1.006. And
Yeah.
this one by this one is?
That,
Yeah, so
minus,
it's
yeah.
M times by 1.006
yeah.
minus M. But obviously, if you don't know how to do that one, you can just write this one here.
Yeah.
1.006 square, and this one is?
It doesn't say minus M at the end of it.
And
Johnny.
so minus, sorry. Yeah,
It doesn't.
you take out the minus M, then you're left with the 1.006 plus 1.
Yeah.
That's what you do. And then you have to do AN. So you just have to go for maybe A3. You can pick up the pattern, right? What's A3 then?
A3 is that whole thing minus.
No, you don't have to do it. Just to tell me the end result. So maybe you can go through. So this whole thing, of course, it's this whole thing times by 1.006 minus M, right?
Yeah.
It's going to take a long time. So now you have this result. Let's just use a pattern. That's fine. Okay.
Okay.
So in this question, so A3 is 10,000, 100,000.
Yeah.
And then 1.006 to the power of how much?
3.
3. And then minus M, and then?
How
much?
1.6.
1.006 square?
Squared, yeah.
1.006?
Yeah.
Plus 1, right?
Yeah.
Now, AN is?
Yeah.
AN is? Therefore, $100,000?
Yeah.
1.006 to the power of N?
Yeah.
Minus M? 1.006 N minus 1?
Yeah.
1.006 N minus 2?
Yeah.
All the way down to?
Oh,
1.006 square, 1.006 plus 1, okay?
yeah.
Then you write this one as, then you can just copy this result here.
Oh, true.
How easy is that? See?
Yeah.
That's a 1.006 N, and then just copy this result here. M bracket, because this is a series, right?
Yeah.
So if they give you the result, you can just use it.
Yeah.
So this is equal to 1.006n minus 1, 0.006 there.
Yeah.
But obviously this result comes from the fact that Sn is equal to a Rn minus 1, R minus 1. Okay?
Mm-hmm.
Now let's go through so they tell you actually the M. So M is 780. So it says that after 120 monthly repayments, the money owing is this one. So that's very simple.
Yeah.
All right, we just have to look for a 120, right?
Yeah.
And this is the formula. And all you have to do is just, well, that's 10,000 there. So it's 100,000 here. So 1.006 to the power of 120 minus 780 here.
Mm-hmm.
That's how much you're paying. And then this is a 1.006, 120 minus 1 over 0.06006.
Right.
So this, what it's saying is this. After 120 payments
Yeah.
at $780 per month, you're paying
Mhm.
$750 every month, $80 every month.
Yeah.
The amount owing will drop down to 68,500. So if you just do this calculation in
Does
the
that say 780?
that's 780 here.
Yeah.
Yeah, not
Yeah.
750.
Yeah. Okay.
So this will drop down to 68500.
Yeah.
So that's that question there. The question 3, very easy.
Yeah. Could you scroll across again, Johnny?
Yep.
Just wanted to quickly double check something. Ah, right. Okay.
Yeah, so
Okay.
this is what loan
Got it.
repayment is all about.
Right.
So there's nothing serious really.
It's not too hard. You just got to practice it and
Yeah,
get the
just get used to it,
concept
okay?
there.
That's all.
Because
Number
it's like a
4
new
is immediately
concept.
after making 128th payment, same makes a one-off payment, reducing the amount owing to. So this is something we can maybe discuss next time.
Yeah, true.
But I just want you to focus on the derivation of all of this.
Okay. What do you mean by
So,
derivation?
just derivation of the AN.
Oh, the concept of it.
Yeah, so you just have to know how to figure out the AN like that, okay?
Mm-hmm.
In this manner.
Mm-hmm.
All right. So I'm going to send this to you. I'm going to send the video as well. In the
Mm-hmm.
meantime, I want you to go through.
Do you think you can make like a Google Drive with the videos?
Yeah, I'm going to put it on YouTube, but I'm not
Okay.
going to publish it.
Yeah.
I'm just going to give you a link for it. Okay.
Okay, sure.
Yeah. Okay. So I'll see you next time.
Thanks, Johnny. Appreciate it.